Alright, guys, we're going to try this again. I have a different setup so that the camera is not upside down as I record. Alright, so the first question in the problem set talks about Andre and Elena reading a book. Andre has read 1/5 of the book. Elena has read 20 more pages than Andre. So if Elena's on page 55, how many pages are in the book? Well, Lynn has drawn a diagram that we see here, and that diagram is incorrect because it should say 35 if she's read 55 pages and she has read 20 more than him. So it should be 35 in the numbers for the diagram as opposed to 55. And if he's read 1/5 of the book, so 1/5 of some number is equal to 35. So we simply just take that number and multiply it times 5 to solve so that we get x is equal to 175 pages that are in the book. Okay, so 1/5 of some number is equal to 35, so therefore 35 times 5 will give us 175. Okay, all right. The next one, here's a hanger that is imbalanced. We don't know much. We don't know how much any of its shapes weigh. How could you change the number and shapes on it but keep it balanced? You could take, to describe in words or draw a new hanger. So you could remove 2 circles, possibly 2 squares as well, to keep it in balance from each side. You could do it that way. Someone mentioned in class about some of the triangles, but if you remove 2 circles and 2 squares, you could do that to keep it in balance. Okay? All right. The next one says, number 3, match these equation balancing steps with the description of what was done in each step. So in step 1, we see 12x minus 6 is equal to 10. 6x minus 3 is equal to 5 is what we get next. So what we can say is that they divided both sides by 2. So this would be this step. Okay, here we have 6x minus 3 equal to 5, and then 6x equal to 8. So what they did here was they added 3 to both sides. Plus 3 here, plus 3 there would give us 8. And of course the last step says 6x equals 8. You get x equal to 4/3. So they multiply both sides by 1/6. Or you can think of it as dividing both sides by 6 for that one. Alright, so here Lynn solved the equation 8 times the difference of x minus 3 plus 7 equal to 2x times the difference of 4 minus 17. Incorrectly find and circle the errors in her solution. What should her answer have been? So there are actually 2 errors in this particular one. So she did 4 minus 17 and got a positive 13. So this is an error right here. It should be 2x times a negative 13 because 4 minus 17 is a negative 13. And then there's another error in the problem where she should have added 8x to both sides, I believe. And she did not do that correctly. Actually, she should have subtracted 8x. So what she did was she added. So in this step from here to here is where she went wrong. She should have subtracted 8x from both sides. And what she did here was she subtracted on this side, but added on this side. So she should have subtracted 8x, but she added. Okay? So when you solve it, your value of x is actually 1/2. And I'll show you how to solve it right now. That way we'll know what to do. So I'm going to rewrite it here. So we have 8 times x minus 3 plus 7 equal to 2x times 4 minus 17. So sometimes when you're looking for the error, it's best to just go ahead and solve it. So we have 8 times x, which is 8x. 8 times 3 plus minus 24 plus 7 equal to 2 times 2x times 4, which is 8x, plus, I'm sorry, not plus, get it right, plus 2 times 2x times minus 17, so that's going to be a minus 34x. And you could have actually done the math inside of there first before you actually did the distributive property. So let's combine like terms. So we have 8x minus 17, because minus 24 plus 17 is minus 24 plus 7 is a minus 17, equal to 8x minus 34x is going to be a negative 26x. So then we're going to actually continue by solving. So let's go ahead and subtract 8x from both sides, because I already have this number over here that if I subtract 8x, it'll be by itself. So I end up with a negative 17 equal to negative 26x minus 8x is going to be a negative 34x. And I'm going to divide both sides by a negative 34. So a negative divided by a negative should be a positive. So 17 is 1/2 of 34. So 1/2 is equal to x, as it should be. Okay. All right, number 5. Noah wanted to check his solution of x equals 14/5 for the equation 1/2 times the difference of 7x minus 6 equal to 6x minus 10. By substituting 14/5 for x, he writes the following. So find the incorrect step in Noah's work and explain why it is incorrect. So he has an incorrect step here. From here to here is his incorrect step. So this looks like a whole bunch of math that he did that doesn't seem to be right, but it's right up until the last, these two steps right here. So he does the 1/2. He multiplies the 1/2 part in the first one by 2 to get rid of the 1/2. So when he does that, the 1/2 goes away on this side, leaving just what was left here in the inside. And then 1/2, multiplying by 2 on the right hand side gives us 12x. Or as we say, 12 minus the 20. So those two steps are right. But right here, he's trying to get rid of the fifths, the 14/5 part. So he's trying to get rid of the 5 in the denominator. So he multiplies both sides by 5. So when he does it, he distributes here, and he gets rid of the 5 in the denominator. So all you have is 7 times 14, which is correct. But he did not do the 5 times minus 6. That here is where the error is created. And the same thing goes here over here. Times the 5, it gets 12 times 14, but he forgot to do the 5 times the 20. So what he should have had was 98 minus 30 equal to 168 minus 100. That would have given him the right information. And then once he does that, he ends up with 68 equals 68 to check the solution. So that ends up checking out to be correct. Okay, so he made the mistake right there. All right. So without solving here, number 6 says identify whether this equation has a positive solution, negative solution, or zero solution. So therefore, this will be a positive solution. And if you want to make sure, if you add 5 to both sides of this particular equation, you get 3x is equal to 2, because a minus 3 plus 5 is going to end up being a positive 2. So therefore, when you divide, you get x is equal to 2/3, and it is positive. Okay. Here to solve the equation, so let's solve it. I'm going to write this as plus a negative 5 and plus a negative 1, because you need to understand that when you have a minus sign in front, that it will end up changing what is being done in the parentheses. Okay, so we're going to distribute x plus a negative 5 times x minus 1. So this ends up being x minus 5x plus 5, because this becomes a plus negative 1. So a negative times a negative is a positive, equal to x plus a negative 2, and again plus a negative. So plus negative 3 times negative 1 ends up being a positive 3. Let's combine like terms. So x minus 5x is a negative 4x plus 5 equal to x plus a negative 2 plus 3 is going to be x plus 1. I want to keep my x positive, so let's go ahead and add 4x to both sides. We end up with 5 equal to 5x plus 1. And then subtract 1 from both sides. We get 4 is equal to 5x. Divide both sides by 5. I don't have much room left, but divide both sides by 5. You get x is equal to 4/5. Now, we're not done. You got to plug the 4/5 back into the equation. Actually, no, you don't. Not this one. It's a different one. I'm thinking about number 9. But 4/5 is your answer right here for this one. My fault. I'm thinking about the systems where you have to go back and plug in. All right, number 8 right here is to solve the system of equations. So we have y equals, y equals 2x. So therefore, x minus x equals a negative y, or the opposite of y, plus 6. So what we're going to do is we're going to plug in our y answer for where we see x, or our y value. So let's rewrite it as x equal to the opposite of, so y has a value of 2x plus 6. So x is equal to the opposite of 2x plus 6. So here we go. Let's rewrite this as it is. X equals negative 2x plus 6. Excuse me. Let's go ahead and solve by adding 2x to both sides. You get 3x is equal to 6. When you divide both sides by 3, you get x is equal to 2. Okay. All right, number 9. So again, we have y equals 3/4 x. So therefore, we're going to actually solve by putting in the value of y where we see y in our equation. So let's do it again. So 5/2 x plus 2 times the value of y is 3/4 x. So we're going to do that as 3/4 x equal to 5. Now remember, when you multiply fractions, you change a whole number to be a number over 1. So we're going to have 5/2 x plus 6 over 4 x equal to 5. So we recognize that we can't add these together, even though they have like terms and x terms, but we have to get a common denominator in order to add them. So we're going to change 5/2 to have a 4th. So we know that we can multiply the 5 and the 2 by 2 to get 10 over 4x plus 6 over 4x equal to 5. Now we can add them together and make a number that we can use. So let me continue this on our paper. So we end up with 10x over 4 plus 6x, 6/4 x. So it doesn't, sorry, 10/4 x. Let me write it like that. There we go. Equal to 5. Combine like terms, so we can add 10 plus 6, that's 16 over 4x equal to 5. And then we can reduce this. 16/4 is equal to 4x equals 5. Divide both sides by 4. So we end up with x as a value of 5/4 to solve. 5/4. Okay. Now we got to plug it back in. Oh, we forgot to do it in number 8. So we'll go back to number 8 and plug the x in to find the value of y. So we got to plug it back in to figure out the value of y. So if y is equal to 3/4 times x, let's replace that by saying, okay, y is equal to 3/4 times 5/4, because that's what x is. So 3 times 5 is 15. 4 times 4 is 16. So y is equal to 15/16. Okay. Now let's go back to number 8. I forgot to plug in the value of x to find the value of y, which is easy. So if x is equal to 2, so we have y is equal to 2 times x, so y is equal to 2 times 2, so then therefore y is equal to 4. Okay. All right, number 10 at the bottom says that we want to take this particular equation and write it so that it has no values that are true for x, all values are true for x, and then just one value is true for x. So to do that, no values are true. This number here that we are adding will have to be anything other than 8. So any number other than 8. Because if we use 8, it makes it true for all values. So any number, it could be 5, negative 8, it could be 12, but anything other than the number 8. For all values, we will put a 8 here. So that way the left and the right are exactly the same. So that means any number you put in for x will be true for all values. And then for just one value, so remember we talked about in class that for just one value, you have to have different coefficients. So it could be just simply x in that blank. You could have 5x, you can have 8x, 7x, but it has to be a coefficient type number, because if you add another constant, then it won't be true for any values. So you can do x, like I said, it could be 2x or anything with x that you can have, as long as it is just a term with x. Okay. All right, the back side, number 11. So Elena began to solve the equation. When she got to the last line, she realized that the solution had values that were true for all values. So how could she tell? So basically, she could tell by simplifying the last line to see they are the exact same. Okay, to see they are the exact same. So if she were to combine like terms here, you get 36x plus 18. If you were to combine like terms here, you get 36x plus 18, because 24 minus 6 is 18. Okay. All right, so here, to own and operate a home printer, it costs $100 for the printer and an additional 5 cents per page. For ink to print out pages at an office store, it costs 25 cents per page. Let P represent the number of pages. So what does the equation 100 plus 500p equal to 2500p? This is the home printing equal to the office store printing. That's what it represents for that equation. So when those two are equal is what it tells us. Okay? Trying to keep it so you can see. All right, so then it says the solution to that equation is P equals 500. What does that solution mean? This means the value or the amount of copies, rather. The amount of copies, or printing, however you want to call it, you can make, and it is equal. Equal meaning equal at the store and at home. So I don't have a lot of room to write that, but I was trying to say that in so many words. So at 500 copies of whatever you're doing, it's equal to print at home or to print at the store. Okay. So I'm guessing probably anything less than 500, it would be cheaper to print it at home. Anything greater than 500, it would be better to print it in the store. Okay, possibly. All right, so on the coordinate plane shown, one line shows combinations of dimes and quarters that are worth $3. The other line shows combinations of dimes and quarters that total to 12 coins. But this is number 14, 15, and 16. So it's name one combination of coins shown on the graph. So if you look at your graph, which you have right here, you're looking for combinations where you have 12 coins. So you can have right here at the bottom, you see you have 12 quarters and 0 dimes. Okay, 12 quarters and 0 dimes, or you can have 12 dimes and 0 quarters. So therefore, it's just 12 coins. So it doesn't matter how you shake it as far as which ones you choose, just having 12 coins. So you can have 12 quarters and 0 dimes. You could have another combination where you have, let's say, 8 quarters and 4 dimes. You can see that, 8 quarters and 4 dimes. So it can be any combination where you have 12. So it says name one combination of coins on the graph that show a total of $3. So if we look at it, dimes and quarters that total $3. So right here we have, what's that, 6 and 15, it looks like. I believe 6 quarters and 15 dimes. So we can have 6 quarters and 15 dimes. That's $3, because 6 quarters is $1.50. $15 is another $1.50, so that would be $3. Okay. So then, how many quarters and dimes would you need to have both 12 coins and $3 at the same time? So in that case, you would have to have just 12 quarters and 0 dimes. Because other combinations do not give you 12 coins. Okay. All right. So here we have Andre and Noah started tracking their savings at the same time. Andre started with $15 in deposits and $5 deposits per week. Noah started with $22.50 deposits per week. And let me see, I need to get a ruler or straight edge in order to show the graph. Just give me 1 second. Get a ruler so that you can see this. So the graph, so that they already have a line, and that line is Noah. So what we're trying to do is find Andre on our graph. Here's the graph, okay, that you should be able to look at as well. So we're trying to find Andre and his graph that he's supposed to have for his equation. So it says write the equation for Andre's savings and graph it alongside Noah. So Andre started out with $15 and saves $5 per week. So his would be y equals 15 plus 5x. If you wrote it as y equals 5x plus 15, that's fine. Okay, that's fine. You can do it that way. So let's go ahead and graph his line. So he starts at $15. We're going to put a point right here. And he goes up $5 each time for his savings, because he saves $5 per week. So we're gonna have, I'm gonna put some points on the graph. That way we can make a straight line. So 25, 30, 35, 40. Here we go. So there is where our line will meet for Noah, and my ruler's casting a shadow right now. So let me turn it so I can see it. Pardon the turn, but I want to make sure I draw the line correctly. All right, so here is Andre. So I'm going to write Andre here. And his is y equals, I'm going to rewrite it now as 5x plus 15. So what does the intersection point mean in this situation? So the intersection point is at 5 weeks and $40. So that intersection point means at 5 weeks, they have the same amount, is what that means. Okay? At 5 weeks, they have the same amount of money saved. Okay? All right, we got 2 more questions, or actually, no, not 2 more questions, but 2 more diagrams to go through. Number 19 is talking about a milkshake that Diego and Lynn are drinking. And they both start out with the same amount of milkshake in their glass or their cup, however you want to phrase it. But we got to figure out exactly how to understand what it means. So determined to finish her milkshake before Diego, Lynn drinks her 12-ounce shake at a rate of 1/3 an ounce per second. Diego starts with his usual 20-ounce shake. I'm sorry, so they had 2 different ounces of shakes. 20-ounce shake and drinks at the same rate as before, 2/3 an ounce per second. So 9 says, graph the situation on the axis provided. What does the graph tell you about the situation, and how many solutions are there? So 1 starts out at 12. Okay. So she drinks at a rate of 1/3 an ounce per second. So if it's kind of hard. So if she says 1/3 an ounce per second. So at the end of, let's say after 3 seconds, so 1/3 of an ounce per second. So 3 seconds she drinks a whole ounce. So let's say that we go down to, that's going to be kind of hard because that's not going by ones. So let's see if we can plot. So 3 seconds to drink an ounce. So we can say, so 6 seconds. 6 seconds. She has 2 ounces that she's taken out. So that would be 6 and 10. Okay. 6 and 10, and then another 6 seconds. It's hard to say. Another 6 seconds, she has devoured another 2 ounces. So if we go to 12, she should have 8 ounces out of the way at 12, and so again another 6 seconds. We can say that she's taken out 2 more ounces, so that would be 18. She is down to 6 ounces. Okay, everybody see that? And then another 6 seconds, so that's going to be 24. She's down another 2 ounces, so that'd be 24 and 4. So that's going to be Lynn's line. So let's go ahead and graph that. For Lynn, okay. All right. And then Diego has 20 ounces, so he starts up here at 20 ounces. And he drinks his shake at 2/3 an ounce per second. So he does a little bit different. So if we do 3 seconds, he has devoured 2 ounces. So 3 seconds, he's down to 18 ounces. So another 3 seconds, he's down to 16 ounces. The line's kind of faded. Another 3 seconds, he's down to, that would be 14. But that looks a little bit different. 14, 15. So yeah, 14. There we go. So it would be 9, 14. Right here, the line's kind of faded. It's not really there. And then we keep going. So let's go ahead and draw so we can see the pattern of what's going on with Diego. So now we have a point of intersection. You see that point of intersection right here? So that's where they both intersect. So this is going to be Diego. Let me label a line. And this is going to be Lynn. So it says, what does the graph tell you about the situation and how many solutions are there? There's only one solution because there's only one point of intersection. And it tells us that at 24 seconds, they both have 4 ounces remaining. Okay? They both have 4 ounces of milkshake left at 24 seconds. So if we look at our graph, it takes Diego 30 seconds to finish his drink. It takes Lynn 36 seconds. So she does not finish before he does. Okay? And we can clearly see that because the rate that he drinks his shake is faster than hers. All right, the last two. So given the lines shown here, what are 2 possible equations for this system of equations? It could be any particular set of systems that you write for this, but it's just to recognize that you understand the concept that's trying to be presented here. So I have 2 lines that are clearly parallel. We learned in class that parallel lines have the same slope. So if I look at my graph, we know that this line here above the x will represent positive numbers, and this line here, which is our y-axis, below the x represents negative numbers. So your equations should show that you understand that one line crosses in the positive part of y, and the other line crosses in the negative part of y, excuse me. So let's go ahead and write 2 equations that we have with the same slope. So we can write y equals, let's say 5x plus, I don't know, let's say plus 1. This like might be plus 1. And then this one would say, it is y equals 5x, let's say, well, maybe minus 6. We don't know how far down it is, but maybe minus 6. So I show that I know that the slopes are the same, and I show that these 2 lines cross at different points on the y-axis. So that could be your equation that you write. It doesn't have to be the exact equation, but that could be the equation that you write. The main thing is that you recognize that the lines that are parallel have the same slope. And it says, how many solutions does this system of equations have? Explain your reason. There are 0 solutions for this, and that is because, my spelling, B-A-C-A-U-S-E, because the lines are parallel, therefore they never intersect. So if they don't intersect, there's no solution. Okay? There's no solution that you can have. So this is what the graph of a no solution system of equations would look like. They would be parallel lines. Okay? All right. That is the problem set that you have for the test. I will also, I'm trying to get finished with the quizzes, guys. So what I'm going to do is actually upload the answers so that you can see the answers and go back and check your work. And I'll actually show a picture of the work so that way you can check if I can't get them graded for you all of you to see your grade, which I think is more important that you know the actual process. All right. See you guys tomorrow in class. Bye-bye.